So your first slide here has your daily quiz for today. It's using your geometric mean with your similar right triangles from yesterday. So please go ahead and solve for x and y here. When you finished your daily quiz, you can move on to the rest of the video. Now today we're going to start actually working with the trig part of this right triangle module, and we are going to introduce our three trigonometric ratios today. Now, for your daily objective, by the end of today, we are going to be able to, 1, write trig ratios, 2, you are going to be able to calculate trig ratios in your calculator, and 3, you are going to be able to define the relationship between the sine and the cosine of complementary angles. Given that objective, here is your mastery ticket for today. So for number 1, you are going to be writing your trig ratios. For number 2, you are going to be calculating. And then number 3, you are going to be answering a question involving some complementary angles there. So by the end of class, and you'll have this slide again at the end of your lesson, you will be able to answer these 3 questions that you have. So what we're going to be talking about today, the basis of the lesson, is how do you write those ratios that occur in a right triangle. So we have 3 trig ratios, and we want to talk about how do we write them. But before we can talk about how to write those 3 trig ratios, you have to understand the relationship between the parts in a right triangle. So what I have here is a picture of a right triangle, and what we're going to talk about are the relationships between the reference angle and the 3 sides in that figure. Now, first of all, in a right triangle, you are always going to have a right angle in one of the corners, wherever that right angle may occur. So our right angle is here. Now, there are 3 sides in a triangle, and in a right triangle, 2 of the sides are legs, so the red and the green here are the legs, and there is also 1 hypotenuse. Now, we've been talking about pretty much all year, and you've heard about this in the past, that the hypotenuse is opposite the right angle. So wherever your right angle is, the hypotenuse is always going to be opposite that side. So this word right here, your hypotenuse, is nothing new. Where the right angle is located and where the hypotenuse is kind of a review. What we are introducing today is the idea of having a reference angle in the triangle, and how do we identify the opposite and the adjacent sides based on that reference angle. Now, first of all, the reference angle is going to be given to you. It's whatever angle you are referencing in the problem. So I will either identify it by letter, so if I say angle A, or I mark it with something, whether there's a variable or there's an angle measure here, your reference angle will actually be referenced in the problem. That's why it's called a reference angle. Now, that reference angle can be either one of the other 2 angles in the triangle. It cannot be the right angle. So the reference angle will be one of the other 2 angles. So for the sake of our example problem here, I am calling this angle right here my reference angle. I have identified it with an arc, and I'm going to identify that as being my reference angle. Now, the opposite and the adjacent sides are always with respect to that angle. So that's why in all the problems that we do for this module, the very first thing that you are going to have to do is find your reference angle, because the sides are dependent on where that angle is. So if you look at where the opposite side is located, you will notice that the opposite side is literally directly opposite from the reference angle. That is why we call that the opposite side. Now, as for the adjacent side, we know that the word adjacent means next to or touching. So if you think about where the adjacent side is located with respect to this angle, look how the adjacent side actually touches that angle. There are two sides that are going to make up the reference angle. One of them has to be the hypotenuse. The other one is going to be the adjacent side. So your adjacent and your hypotenuse will always make up your reference angle here. The opposite side will be clear opposite across the triangle. So I usually find the opposite easier to find than the adjacent, because I always draw my arrow straight through the triangle here. Now, the reason that we had to go over these 3 relationships is that we are going to actually use those to write our trig ratios. Now, on this line here, list out your 3 trig ratios, and up at the top is kind of a weird word. Some of you may have seen this before. Sometimes you cover this a little bit in Algebra 1, but it is the phrase SOHCAHTOA. And SOHCAHTOA is how we remember our trig ratios. There are going to be no trig ratios on your reference sheet for the 10 ready. And I can tell you right now that when we were in the computer lab, those 4 questions that were on part 1 that you all kept asking me, can I do this question, can I do this question, those were all trig questions. They had sine, cosine, or tangent in the problem. You are going to see a lot of trig on the first part of the 10 ready test. So you have to have a way of remembering which set of sides goes with sine, which set of sides goes with cosine, and which one goes with tangent. That's where SOHCAHTOA comes into play. So whenever you are doing a trig problem, I am going to tell you to write SOHCAHTOA on your paper. When you get your test for this module, I'm going to tell you that the first thing you ought to do is put SOHCAHTOA at the top of your test. Now, what SOHCAHTOA stands for are the side measures, the first letters of the side measures for each one of our trig ratios. So we have 3 trig ratios: sine, cosine, and tangent. And those 3 trig ratios have certain sides associated with it. Now, a ratio is a fraction, so that's why all 3 of these are written as fractions. So if I am trying to find the sine in a triangle, if I'm trying to find the sine of one of the angles, I am going to use opposite over hypotenuse, so that's where the SO part comes from. If I am asked to find cosine, I am going to use the adjacent and the hypotenuse. That's where the C part comes from. And if I am trying to find the tangent of an angle, I am going to use opposite and adjacent. So that's where the TOA part comes from. You have to memorize SOHCAHTOA. There are no trig ratios on your formula sheet for 10 ready. So I will not be giving them to you on the test either. You have to know SOHCAHTOA. So in our first set of examples here, we are asked to find the sine, cosine, and tangent ratios for a couple of angles. So the first thing that I'm going to do is up at the top, I'm going to put my SOHCAHTOA so I remember which one is which. So for number 1, it says, what are the sine, cosine, and tangent ratios for angle T? So the first piece of information that you have to have in a trig question is you have to have a reference angle. So you've got to identify your reference angle either in the problem or on the diagram. Sometimes it is marked on the diagram, sometimes it is given to you in the actual question. In this particular problem, it's given to us in the question. So I know that my reference angle is angle T, so I'm going to mark that angle because that's going to determine my side labels. Now, the next thing that I'm going to do is I am going to label my sides either opposite, adjacent, or hypotenuse. Now, first of all, the most obvious one is always your hypotenuse, because your hypotenuse will always be opposite your right angle. That is the definition of the hypotenuse. So I know that the 17 here is my hypotenuse. Now, to locate the opposite side will always be directly opposite the reference angle. So to find the opposite side, you can always draw an arrow straight through your triangle from the reference angle to the opposite side. So my opposite side is going to be 8. Now, the last side that we have is our adjacent side, and I always save the adjacent for last because it's probably the most difficult to identify. The adjacent side is the side that actually touches the reference angle but is not the hypotenuse. So the adjacent side can sometimes be kind of dependent on the hypotenuse, so I always find the hypotenuse first and then I'll leave the adjacent for last. Now, writing our 3 trig ratios. First of all, for sine, I'm going to go up to my SOHCAHTOA. My sine ratio requires an opposite and a hypotenuse. So I know that sine is equal to opposite over hypotenuse. And looking at my actual triangle here, my opposite is 8 and my hypotenuse is 17. So I'm going to write that as 8 over 17. So my sine was 8 over 17. Now, if you can simplify your fraction, you have to simplify your fraction. So 8 over 17 does not simplify. They do not have a common factor, so I cannot simplify 8 over 17, but if they did simplify, you would have to simplify those values. So next up, we're going to look at cosine. And cosine is equal to adjacent over hypotenuse. So that's the k part of SOHCAHTOA. So I want adjacent and hypotenuse. So my adjacent is 15 and my hypotenuse is 17. So that's 15 over 17. And once again, 15 over 17 does not simplify because there is no common factor. Now, lastly, we have our tangent ratio. And tangent, based on SOHCAHTOA, our tangent requires opposite and adjacent. So that's the TOA part. So opposite over adjacent. And my opposite side here is 8, and my adjacent side is 15. So that's 8. Gotta switch back to my pen. So that is 8 over 15. And once again, 8 over 15 does not simplify because they do not have a common factor there. Now, when you are working with just writing the ratios, obviously we are going to extend this to other problems. So this is just the introduction to trig. So some of you may be feeling like, what was I doing here? There's no final part. There's no answer to my question here. We are just practicing writing the ratios. It is still important for you to be able to write the ratios between the sides because you are going to use those to actually solve in a little bit. So let's take a look at number 2. Number 2, we want the sine, cosine, and tangent ratios for angle P. Now, remember what I said earlier. The key to the problem is the reference angle. You've got to identify that reference angle first because that reference angle will determine the relationship with the other sides. So the reference angle that I'm talking about this time is angle P that is up here at the top. Some of you were looking at these problems and you were saying, well, we're going to get the same answers because they still have 8, 15, and 17. We're actually talking about a different angle this time. So instead of our angle being down here at the bottom corner, our angle is now up here at the top corner. So we're going to notice that our answers are going to be switched up a little bit. They have the same numbers, but the ratios are going to look a little bit different. So with respect to that reference angle, I'm going to go ahead and label my sides. To find my opposite, I draw an arrow, and I'm going to actually draw it in there. I'm going to draw an arrow straight across, so my opposite is 15. I know that my hypotenuse was 17 because it was opposite the right angle here. And that leaves me with my adjacent side, which has to be 8 because that is the side that touches the reference angle and is not the hypotenuse. So that is my adjacent. So going through my ratios, I'm going to start with sine here. And we know based on SOHCAHTOA, the SO part tells us that sine is opposite over hypotenuse, so that's SO. Looking at my triangle, my opposite was 15 and my hypotenuse was 17. So my sine was 15 over 17. And you'll notice that changed from above because my sine up here was 8 over 17. It's now 15 over 17 because I switched angles. Next up is cosine, and that's the k part of SOHCAHTOA, so that's adjacent over hypotenuse, and the adjacent side is 8. My hypotenuse is 17. And then lastly, I've got my tangent, and that's the TOA part of SOHCAHTOA, and my tangent is opposite over adjacent. I'm going to try to squeeze this in. And the opposite is 15, adjacent is 8, so that's 15 over 8. So let's talk about what happens if you switch reference angles up in the problem here. So you will notice I've given you a triangle here, but I've gone back and forth between using the reference angle of D and the reference angle of F. Now, I can tell you that if you're given two different reference angles in the problem, work with the questions that have the same reference angle at the same time. So I'm going to work with number 3 and number 5 at the same time, and then I'm going to work with 4 and 6 at the same time. I'm going to do 3, and then I'm going to have you try to work through 5 as a you do. I'm going to do 4, and I'm going to have you work through 6 as a you do. So let's take a look at number 3. First of all, I'm asked to find the cosine of angle D. So that tells me that my reference angle is angle D. So I'm going to go ahead and mark that reference angle on here as angle D. And I'm going to label my sides according to that reference angle. So opposite would be 16, adjacent would be 8, and my hypotenuse would be 18. So I found opposite here for the 16 because it is opposite the reference angle. The hypotenuse, of course, is the 18 because it is opposite the right angle. And then my adjacent will be my 8 because that side touches the reference angle there but is not the hypotenuse. So that's how I got my adjacent. Now, based on, and I'm going to write this up at the top, my SOHCAHTOA. I know that for my first one here, for cosine, that I need adjacent and hypotenuse. That's the C part of SOHCAHTOA. So I need my adjacent and my hypotenuse. So my adjacent is 8 and my hypotenuse is 18. Now, in this problem, we're going to get fractions that need to be simplified. So if I simplify 8 over 18, 8 and 18 have a common factor of 2, and you can simplify this in your calculator if you want. You've just got to be careful because there are parts of 10 Ready where you cannot use your calculator, so you shouldn't be solely relying on your calculator. You can check yourself. But 8 and 18 have a common factor of 2, and 2 goes into 8 4 times, and 2 goes into 18 9 times. So I've simplified that to be 4 over 9. Now, I want you to try to pause your video right now and try number 5. Try finding the tangent there. I'm going to work through that problem, but I want you to try this on your own with the video paused first. Okay, so for tangent of D, you should have gotten tangent is TOA, so that's opposite over adjacent. My opposite is 16 over adjacent is 8, and 16 over 8 is 2. And you can write that as 2 over 1 or just 2. Now, here's where the problem occurs with most students when they answer this question. And I can guarantee you there's going to be a question like this on your module test. So please be careful because these are the most missed questions and they're not that hard. When you switch reference angles, you need to switch your labels because when you switch reference angles, the relationship is not still opposite and adjacent where they are or where they were before. So let me explain what I mean. Next up, we're going to do question 4 and question 6. Question 4 and question 6 use angle F as a reference angle. I want you to look at the labels that I have on the triangle right now. Notice that they do not match. This side right here is not opposite that reference angle anymore. So when you switch reference angles, you need to create new labels for your triangle. So I always use 2 different colors to show my 2 different labels on here because I kind of get mixed up otherwise because I've got stuff crossed off and all sorts of stuff going on. But I will use 2 different colors, one for each reference angle, so that I know when I'm doing that particular problem that I am looking at one color versus the other. So let's label the triangle according to that reference angle. So this side is now going to become the opposite. This side over here, the 18, is still the hypotenuse, but I'm going to rewrite it in red. The hypotenuse always stays the hypotenuse. You can't change the hypotenuse. And then this side over here, the 16, is going to become our adjacent because this side now touches the reference angle. So I have new labels for my triangle. So my hypotenuse stayed, but my opposite and my adjacent switched. So going through and answering our questions here, sine is the SO part of SOHCAHTOA, so that's opposite over hypotenuse. My opposite is 8, and my hypotenuse is 18. So you will notice how your cosine here actually matches your sign here. That's because I switched the opposite and the adjacent. So when the opposite and the adjacent switched, these two values actually ended up staying the same. So sine for one angle is actually going to equal the cosine for the other. Now, and it would help if I switch back to my pen here. Simplifying that, we've already simplified that. That is 4/9. Now, what I want you to do is try number 6. So I want you to pause your video, try number 6 on your own, see if you can answer that question. I'm going to answer it on here, but I want to see if you can get it before I do. So go ahead, pause your video, and then we'll work it out on here and you can check your answer. So you should have had cosine here is the ka part of SOHCAHTOA, so that's adjacent over hypotenuse. The adjacent is 16. The hypotenuse is 18. And then, of course, I know 16 and 18 have a common factor, so I know that has to be simplified. Their common factor is 2. 2 goes into 16 8 times. 2 goes into 18 9 times. Now, what we're going to work on, along with being able to write the basic ratios here today, are just introducing you to some of the calculator basics of how to use trig ratios. So you are able to put the trig functions in your calculator, and I want to go through how to do that before we look at the equations tomorrow. So I'm not spending a ton of time teaching you how to put that in the calculator while we're working with the equations tomorrow. Now, the first thing that you need to know is when we are dealing with the sine, cosine, and tangent here, the sine, the cosine, and the tangent are always being taken of the angle. So when we're talking about sine of something, it's sine of some angle. So sine of 52 degrees, or sine of 80 degrees, or sine of 23 degrees. So whatever angle measure you have is what goes with the sine or the cosine, and that's going to be really important, and we're going to focus on that for the next couple days. Now, that being said, please remember that angles are always degree measures. So, if you are given an angle measure, you can calculate a sine, cosine, or tangent function in your calculator. Now, before you do that, you have to be careful because when you reset calculators, this goes back to the old mode, the old setting in the mode. So before you start any of these questions, and you should be doing this every day, and there's a note down here that explains it, every day that you are working with trig functions, you have got to make sure that you check this in your calculator, because if this is not set up right, you will literally get every single question in the trig part wrong. That will cause you to get every question on your Module 6 test wrong, and all those questions on the 10 Ready test wrong too. So what I want you to do right now is I want you to go to mode in your calculator. It's up near the top. It's right next to the second button on your calculator, I believe. And I want you to make sure in the mode menu, I want to make sure that your calculator is in degrees, not in radians. We do not work in radians in this class. You will work in radians next year in Algebra 2. Now, this is a setting that as long as you do that the first time, as long as you check it, it will not go back unless you reset your calculator. But if you happen to have a different calculator, because you know you don't use the same calculator every day in here, if you happen to have a different calculator tomorrow, you've got to make sure that that setting is right in there. So every day when you come in here, make sure that you check that, make sure your calculator is in degrees. Once you're in degrees, you can press second and quit and go back to your home screen. Alright, so to talk about how we put these in our calculator here, pretty easy to put a trig function in the calculator. You probably don't even need instructions, but I typed them up just in case. First of all, your trig buttons are right over here. I boxed them in red, so there's your sine, there's your cosine, and there's your tangent. Please make sure, and I always I've brushed over this in the past and didn't realize I needed to mention this, so I want you to make sure you listen to this part. You've got to make sure you press the appropriate trig button. Not every function is a sine function or a cosine function or a tangent function, so it's all dependent on whatever you have in that particular problem. So if it's a sine problem, make sure you use the sine button. If it's a cosine problem, use the cosine button, and if it's a tangent, use the tangent. And like I said, I've not said that in the past, and I've had some confusion about that, so I just wanted to make sure I clarify before we get too far. So the first thing that you're going to want to do is press, like I said, the appropriate trig function button. So let's say you're finding the sine of 30 degrees, and I put an example down here at the bottom. You would press your sine button in the calculator, and you can actually practice doing this real quick if you want to. Press your sine button. Then you are going to enter your angle measure. So this one was sine of 30 degrees, and make sure that you close your parentheses there. It will still find it if you don't close the parentheses, but you're going to learn tomorrow when we do our trig equations that if you don't close that parenthesis, it messes up the equations that we do tomorrow. So I want you getting used to actually closing that parenthesis today. So I made sure I put that in the direction. So you want to close your parentheses and then you just press enter, and it will give you the value there. So if you want to go ahead and actually practice a couple of these, put these in your calculator. I gave you an example here that came from the screen. So I press sine, put in 30, close my parenthesis. I press cosine, put in 60, close my parentheses, and then I put in tangent, 26.57, close parenthesis, and you see what I got. So in our examples, we have some questions here where we're just going to practice putting these in the calculator. Pretty straightforward, so not a whole lot to these questions. I'm going to do the first two with you so that you can actually check your answers, and then I'm going to have you work through 3 through 6 on your own. So for number 1, and we're just making sure that we get the same answers. These are some of the easiest questions that you do, so I really don't need to do these with you, but I just want to make sure that your calculator is in the right mode and you're putting it in correctly. So for number 1, I'm going to press the sine button. I'm going to put in 80. I'm going to close my parentheses, hit enter, and I get 0.985. And usually we round trig functions to 3 decimal places, sometimes 2, but normally to 3 decimal places. So I rounded that to 0.985 to 3 decimal places. All right, so let's try number 2. We're going to do cosine. I'm going to press the cosine button, 41, and then I'm going to close my parentheses, hit enter, and I get approximately 0.755 when I round to the nearest thousandth there. So you are rounding to the 3rd place after the decimal, so that's 7 rounds to 4 up. Now, I'm going to have you go ahead and try 3 through 6. I want you to practice putting these in the calculator because you're going to be using the calculator throughout this module to figure out these trig functions. Now, last part for our lesson today was to talk about what happens when we have complementary angles. Now, first thing we've got to do is we've got to go back and review a vocabulary word from Module 1. And that vocabulary word is complementary angles. And complementary angles are 2 angles whose sum is 90 degrees. Now, what statement I have here is because we are dealing with right triangles, the other 2 angles, so the 2 angles that are not 90 degrees already, are always going to be complementary, and I want to know why. Well, let's think about right triangles here. We know that in a right triangle, we have a right angle here, and we know that the measure of that angle is already 90 degrees. Now, we learned in Module 3 that the sum of the measures in any triangle is always 180 degrees. So if I already have a 90-degree angle in my triangle and I subtract out that 90 degrees, 180 minus 90 leaves me with 90 degrees. So that means that these last 2 angles that I have here are always going to add to be 90 degrees because that's what I have left in the triangle. So these 2 angles here and here are always going to add to be 90 degrees. Well, that is the actual definition of being complementary, is that they add to 90 degrees. So that's why in every right triangle, the other 2 angles, the ones that are not the right angle, they are always going to be complementary to each other. So every triangle that we are talking about in this module, these 2 angles right here can always be defined as being complementary. So what we're going to do real quick is we're going to do a quick investigation. So we're going to calculate each one of the values for these triangles. So I gave you 3 right triangles here, and I've asked you to find the sine of angle A, and I've asked you to find the cosine of angle C in each one of the triangles. So let's look at our first triangle here. So we want to find the sine of angle A. Well, angle A is 70 degrees. So I'm going to put in my calculator sine of 70 degrees. So let me write that up here. I'm putting in sine of 70. That's what I'm putting in my calculator. So I've got sine of 70, close parentheses, hit enter, and I end up with 0.940 when I round that up. It's 9396, so 940 when I round that up. Now, for the second part here, I want to find the cosine of C. So looking at angle C, I want to find the cosine of 20 degrees. So here I'm going to be doing cosine of 20. So cosine of 20, and I end up with 0.940. What do you notice about these two numbers right here? All right, so let's see if we can continue. I'm not going to answer that question about what do you notice. I want you thinking about that for a second, and let's see if what you notice continues in our pattern here. So let's go to question or triangle 2 here. I want to find the sine of angle A. So I'm going to do sine of 54 on this one. So sine of 54, close parentheses, and that gives me 0.809. Now, I also want to do cosine of C. So I'm going to look at angle C here, and I'm going to do cosine of that angle measure. So I'm doing cosine of 36. So cosine 36, close parentheses, and I get 0.809. So what do I notice about these two numbers? Think about that for a second. Let's try this one more time. We're going to look at the third triangle here. So I want to do sine of angle A. So that's sine of 66. So I'm going to do sine of 66. And that is 0.914 when it's rounded. And then I'm going to do cosine, because I want C here. I want cosine of C. So I'm going to do cosine of 24. And that gives me 0.914. So what do we notice about these two numbers? So to kind of go back and answer that question, because I've asked it 3 times now, what do you notice about all 3 sets of numbers? You notice that the sine of one angle is equal to the cosine of the other angle. Sine of one angle is equal to the cosine of the other. Sine of one angle is equal to the cosine of the other. So at the very bottom here, it says, what conclusion can we make about the sine and the cosine of complementary angles? So if we have 2 complementary angles, and remember that in a right triangle, these will always be complementary. If we have complementary angles, the sine and the cosine of these complementary angles are always going to be equal to each other. So let's put that in a statement here, and we're going to write it in a full sentence. The sine and cosine of complementary angles will always be equal. All right, so let's apply that kind of idea or that theorem that we just talked about, that conclusion that the sine and cosine of complementary angles are always going to be equal to each other. So my question here is that if the sine of 30 is 1/2, what is the cosine of 60 degrees going to be? So let's think about 30 and 60 degrees. I know that 30 plus 60 equals 90. So are these two angles complementary angles? Yes, they are. And the conclusion that we just wrote based on our findings in the last problem is that the sine of one angle is going to be equal to the cosine of the other angle if they are in fact complementary. So if the sine of 30 is 1/2, then the cosine of 60 has to equal 1/2 as well. So let's look at number 2. If the cosine of 73 is 0.29, what is the sine of 17? Well, let's look at our two angles. I've got 73 and 17. And if I add 73 and 17, that's equal to 90 degrees. So I know that these two angles are complementary, and our conclusion is that the cosine and the sine of complementary angles are always equal to each other. So if the cosine of 73 degrees is 0.29, then the sine of 17 degrees is going to be equal to 0.29 as well. So today we have covered 3 topics. The first topic that we covered was being able to write those ratios. So this is going to be using your SOHCAHTOA. So I would, on the top of your paper, make sure that you write out that SOHCAHTOA. And you are going to be using that SOHCAHTOA to write 3 fractions. So all I want are the fractions. So sine of C is what over what, cosine of C is what over what, and tangent of T is what over what. The second part, you are just practicing putting this in your calculator, so I ask you to calculate the sine of 84. And then for your last question on the mastery ticket, it's about those complementary angles that we were just talking about a second ago. I ask you to compare the sine of 29 to the cosine of 61, and I want to know why, so make sure you answer why.